Hey everyone, Mr. Aarons. Um, Today we're going to be kind of continuing what we've been working on. It should be a pretty simple lesson for all of you if you have been doing the past lessons. What we're doing today is solving one-step inequalities by adding or subtracting. Last week we talked about solving one-step equations, and we know our equations have an equal sign. We also talked about graphing inequalities. Today we're going to be putting the two together, graphing an inequality that was like greater than, less than, greater than, equal to, less than, equal to. We did all this last week. We're going to be putting the two together today. A lot of similar ideas. It should be things that feel comfortable to you if you felt comfortable with those lessons last week. We'll jump right into it. So our first rule right here, we have a property, the subtraction property of inequality. This is very similar to the subtraction property of equations. What it tells us is you could subtract the same number from each side of the inequality. Here's an example for you. We have 7. Is this greater than or less than? I'm thinking about my L. I know L means less than. I see this is going the opposite way. So this is greater than. 7 is greater than 4. So 7 minus 3 is greater than 4 minus 3. You're allowed to subtract the same number from each side of an inequality. As long as you keep it balanced, whatever you do to one side, you have to do to the other. We're doing those same rules. Whatever you do to one side, you have to do to the other. I said that was a super important rule. Still applies. Whatever you do to one side, you have to do to the other. Big rule. Talked about that last week. Still a big rule today. Whatever you do to one side, you have to do to the other. So 7 is greater than 4 is the same as 7 minus 3 is greater than 4 minus 3. We can subtract 3 from each side. Here's a little algebraic version of that. It just tells us A is greater than B, so A minus C, or A minus a number, is greater than B minus C, or B minus a number, as long as those numbers are the same. Same for less than. A is less than B, so A minus C is less than B minus C. It's kind of a lot of mumbo jumbo right now, but once we get some practice here, I think it'll make a lot more sense. So what we're going to try to do is we're going to try to solve, then graph these. Last week we worked on graphing them and solving them. Today we're going to put those two together, and we're going to crush this. So we see n plus 8 is that an L? Nope, that is greater than or equal to. Remember, it has that line underneath, so that means equal to as well. I put our little chart over here for you as well. We have that filled in dot means or equal to, greater than or equal to, or less than or equal to, and that open dot means greater than or less than. So we know that this one's going to be a closed dot on our graph because I already see that right here. Last week we talked about a few things when trying to solve these inequalities or trying to solve these equations. One tip we had was get the variable alone. We're going to be doing the same thing today. And we had a big key term that I'd like to talk about, inverse operations. Our inverse operations are an operation that undoes a current operation. So looking at this right here, I have n plus 8 is greater than or equal to 19. We're trying to get the variable by itself. We know that variable means the letter. To get that by itself, we have to get rid of this plus 8. The inverse operation of plus 8, you're probably thinking in your head right now, is minus 8. We can do that. But remember, whatever we do to one side, we have to do to the other. So if I minus 8 from this side, I also have to minus 8 from this side. Now I simplify. These two cancel out. We know a plus 8 and a minus 8 cancel out. 19 minus 8, you can do that in your head, gets us to n. Keep this simple. And 19 minus 8 is 11. Okay, now we move on to our next step. We figured out what our inequality is here. Now we just have to graph it. N is greater than or equal to 11. I know it's going to be a filled-in dot. I know it's going to be at 11. So I'm going to do that filled-in dot, and now I have to think of what way it's going to go. N is greater than or equal to 11. That means n is going to be bigger. Bigger. If we're going bigger, we're going this way. Always going that way. We're getting bigger. n is greater than or equal to 11. There's our first example. I think you'll catch on quick here, so I'm going to cruise through a few more. Next one we have negative 26 is greater than, because this isn't an L, this goes the opposite way. Greater than, negative 26 is greater than y plus 14. Our goal is to get that variable all alone. To do that, we have to do an inverse operation. The inverse of plus 14 would be, you got it, minus 14. Minus 14 from each side. Whatever we do to one side, we have to do to the other. Treat this just like it's an equal sign. We're going to be doing the same kind of things that we did last week. As I mentioned, these ones are going to cancel out. Negative 26 minus 14. I can also rewrite that as negative 26 plus negative 14. Adding two negatives is just like adding positives. I see 26 plus 14 is 40. Keep that negative sign. I can rewrite this as negative 40 is greater than y. So put that on the chart. I'm thinking here, got to think it out loud, say it out loud in my head. Negative 40 is greater than, I messed up. Can you see where I messed up? Look at this symbol right here. This should be an open dot right there. Negative 40 is greater than y, so that means y could be anything that is less than 40. Negative 40 is bigger than y. Negative 40 is greater than y. Say those out loud in your head to help you think about them. One more here. We got x, or negative 3 is, it's an L, less than or equal to x plus 7. How do we get the variable by itself? We do that inverse operation. Minus 7 from each side. Minus 7 there. Minus 7 there. These ones cancel out. Negative 3 minus 7. So negative 10 is less than or equal to x. Mark on here, I'm going to do a filled in dot because we have less than or equal to at negative 10. Negative 10 is less than or equal to x. So if negative 10 is less than x, that means x is going to be larger. Our graph would go that way. Pretty similar to the stuff we did last week, a little combination of each. I got one word problem, then we'll get into some addition. We got 512 megabytes of memory is usable on your camera. You used 128 megabytes. How much memory is available? So we know we have 512 possible. We know we've used 128, so we have 128 megabytes plus m. I represented was our memory available. 128 plus our memory available is going to be less than our total memory. Set this up. Our goal is to get the variable by itself, like I said on the last page. How can we do that? We have a positive 128 here. I know the order is swapped. Don't let that confuse you. Minus 128 from this side. Minus 128 from this side. These cancel out. Leaves us with m is, less than. Let's do some quick subtraction here. 0, 12, 4, 8, 3. M is less than 384. That's how much memory we have available. Little word problem for you there. A lot of times I like to write out those numbers, use those strategies that help you best for those. Talk out loud. Okay, on to the addition property of inequality. This is going to be very similar to what we just did. Very similar to what we talked about last week. We have 7 is greater than 3. So 7 plus 4 is greater than 3 plus 4. This is telling us that you can add the same number to each side of an inequality as long as you do it to one side and you do it to the other. That works out. Got these right here for you if you want those in your notes. Remember, you're welcome to use notes on tests and quizzes. So our first step here, again, we're going to be trying to get that variable by itself. This time we have n minus 15 is, looks like an L, less than 3. How do we get this variable by itself? We have to do that inverse operation. n minus 15. To undo that, we're going to do plus 15. Whatever we do to one side, we have to do to the other side. These cancel out, leaving us with n is less than 3 plus 15, 18. I'll graph this one more time for you. N is less than 18. I mark 18 on here. Is it going to be filled in or open? If you don't know, go back to your chart. I see it is going to be open because it's not equal to. N is less than 18. That means n is going to be moving this way, going smaller. N is less than 18. Say those out loud when you're graphing them, and I'll help you out. Two more quick examples. We'll fly through them. M minus 13 is, nope, that's not now, greater than 29. To get m by itself, we're going to do the inverse of minus 13, plus 13 from that side. Whatever you do to one side, have to do to the other. You know them. Cruising through this. 9 plus 3, 9, 10, 11, 12. Carry that 1. 42. M, keep the symbol the same. M is greater than 42. If we were to graph that, we would move upward. M is bigger than 42. Last one here. V minus 4 is, it's an L, less than or equal to 7. How do we get V by itself? We do the inverse operation. That's going to be probably thinking in your head, plus 4, plus 4. Whatever you do to one side, you already know it. We got to do the other. V is less than or equal to 7 plus 4 is 11. If V is less than or equal to 11, when we're graphing that, V is going to be smaller than 11. It's less than 11. It would go this way. All right, there's a quick refresher. 12-minute lesson for you. A little combination of our past two lessons. I think you'll crush this one. If you did well in those last week and put some time into those, it should be no problem for you.